All right, so today's topic is on geometry, and I already collected enough problems from some of you. Couple of, homework 1, homework 2, maybe you have 1 or 2 problems on geometry. I did not answer your question, so it's time for me to talk about geometry today. In geometry, right? It's called plane geometry, and so we learned the similarity of triangles. We also learned Pythagorean theory. So question, how do you apply that? I think the most difficult part is to draw addition lines and apply the theory we already learned. Okay, so my first problem will be the following. Okay, how difficult it is. Let's try to see that. I have a triangle. You are not told that this is the right triangle, but you should know that this is indeed a right triangle because 3, 3, 4, 4, 5, 5. So the question is, we are going to draw a line. Okay, this is a bisect that angle, and I have a this side I'm going to have an x, this side I'm going to y. Okay, so we're trying to find everything. Here's a z. Okay, so find the x, y, z. Okay, this is a problem. It's similar to the one on the homework, but we have to find more than that. Okay, right? So it's clear, right? A triangle with 3 sides, and we draw the line bisect. Okay. Right, we draw the line and okay, so question is how do you apply the Pythagorean theory to solve this problem? Okay. The very important step here is to draw this line perpendicular to that. Okay, that is very important. Okay, so let's use A, B, C, D, and E. Okay. First of all, you have to make sure that it is the right triangle. So applying the Pythagorean theory, it is right triangle. It's very important. Okay. Second, you draw the line DE perpendicular to AC. Then you will see where you can use the 2 angles the same. Well, these 2 triangles are congruent. Okay, so the triangle A, B, D is congruent. This means congruent. Okay, and the triangle A, E, D. Okay. So those 2 triangles are congruent. Now, what does that mean? That means that this implies AE going to be AB, right? That's going to be 33. So this also implies that EC is going to be AC minus AE. So 55 minus 33 equals 22. Okay. All right. What else? Because it's congruent, right? We also know that BD equals DE because these 2 triangles are the same. All right. So that means BD is X, so that will be called X. So now I have to apply the Pythagorean theory to how many right triangles do I have? 1, 2. Essentially, we have 2 triangles, right? 2 small right triangles. Okay. So the first triangle here, right? 33 squared plus x squared equals z squared, right? If you want to find z, this is necessary. Okay, you apply the in the right triangle ABD, you can get this relationship. In the triangle and DEC, right? Then you have 22 squared plus x squared equals y squared, right? Because that is going to be x. Here, DE is going to be x. Then you say, okay, I still don't know. I have two equations, I have three unknowns. But remember, x plus y is going to be 44. Okay, that's very important. All right, so you have three equations, three unknowns, then you can solve the problem. So from here, you can get x. Okay, for the problem on the homework, you just need to find x. Okay, in order to find x, I just needed to replace y by 44 minus x, okay? And then you simplify both sides, 44 squared minus 88x plus x squared. So x squared is gone. Then 88x equals 44 squared minus 22 squared, right? Then x is going to be 44 squared minus 22 squared. 88. Let's simplify a little bit, okay? How can I simplify? How can I simplify, right? Well, you have a 44, right? You can factor it. 44 plus 22. 44 minus 22, right? And here's 88 is 8 times 11. I think I'm going to get 66, 6 times 11, 22, 2 times 11, 8 times 11. So 11 canceled out. And I think that's going to be 2 times 11. Okay, so 33 over 2. So that is the answer. Okay, once you get the x, you can get a y. Okay, then you can get a y. But if we go back to equation, you can also get a z, right? So we just, y is going to be 44 minus x, 44 minus, right? It's a bigger number. So what we do is we always write 11 here, 3 times 11 over 2. So I get 8 minus 3, so 5 times 11 over 2, okay? So that's y. Z square is going to be 33 squared plus x squared. X squared. 33 squared is going to be 33, x squared is going to be 33 over 2. Okay? So 1 plus 3 is going to be 5 over 4 times 33 squared. Okay? So z is going to be so this is the answer. So you can get all of the sides you need. Okay, let's go back to the problem. I think the most difficult part is draw addition line in geometry. Okay, and but otherwise, how do you use this this line AD bisect the angle A? Right? How do you use it? Right? So this is a place where you use when you draw addition line, you get two identical triangles. Then apply the Pythagorean theory to two different right triangles. Okay, and you have three unknowns, but remember x plus y is equal to 44 because this is from B to C. Okay. I think this is the most difficult problem. Other geometry problem might be a little bit easier than that. Okay. Our next problem is the following. Okay. I have a circle. Okay. Now, before talking about circle, let me talk about a very important theory. if you have A, you have a B. That's a point P. You draw the line. You get an angle alpha, right? Okay. So if you have another point O, this is the center. If this is a beta, then alpha is going to be half of the beta, right? So that means because O is fixed, right? The center is fixed. So no matter where you move the point P, the alpha is not going to change. It's always equal to half of the beta. So if I draw another line, this is the same alpha, okay? So that angle is not going to change. This is very important property for the circle. Special case. The special case is AB on diameter. O is here. So AB is diameter. In that case, beta is going to be 180 degrees. So no matter where you choose a point P, this alpha is going to be half of the beta, which is going to be 90 degrees. So this, you always get a right triangle. That is a special case. Okay, and no matter where the point P, you always get a right triangle. Okay, that's okay. Second property is if you have two triangles similar, A, B, C, and this is A, that's a B, that's a C. Another triangle much larger, A prime, B prime, C prime. This is a C prime, B prime, A prime. Okay. So if the triangle ABC is similar to the triangle A prime, B prime, C prime, then you will get A over A prime equals B over B prime equals C over C prime, right? Most important thing is, if this is called K, it's called a factor, then the area of the triangle ABC over the area of the triangle A prime, B prime, C prime is going to be, okay, is going to be A over A prime square, which is going to be K square, the square. Okay. Do you know that? How do you prove it? I think all you have to prove is to make sure if you draw the addition line H and H prime, if this two similar, that also implies it is also implies H is over H prime. Okay, so to prove this, it's going to be like a half of AH, right? Half of A prime and H prime. So you get A over A prime, H over H prime. But all of them is going with the factor K. So K times K, right? It's going to be K squared. Right? That's the reason it's the factor of square. All right, so we did a preparation. So now let's do the first problem. If you have a circle, I randomly draw two lines, okay? A, B, C, D, and it's going to be P. Okay. And I have here is going to be 3, 4, 5. I want to know what is X, okay? So what is X, which is a PC from the center to, or from the intersection point of point C. So I'm going to give you this problem. Let you think about it. Okay, so I take a break and you work on this problem. Emma says 20 over 3. Is that correct? Anyone? Has different answers. Some students they say, okay, 3, 4, 5, 6, 6. All right, so let's do this problem. We need a similarity of triangle, right? I draw the line here. See, we have to draw the line. Connect the important points, okay? So my claim is a triangle APB is similar to the triangle, okay, DPC. Okay, why? How to prove it? Okay, how to prove it? All right, first of all, this is cross section, so this triangle alpha is equal to alpha, right? That's first thing. Second, all right, look at the point B and C. Fix 2 points B and C. So A and the D, they should have the same angle because that was the same foot, right? So if this is better, that is better, right? And the same story, gamma, and this will be gamma. Okay, that's why those two triangles are similar. What are the corresponding sides? Okay, so 4, right? So those two triangles are similar. The corresponding side will be beta corresponding to beta. So anyway, so we are going to have 4, right, over x should be equal to 3 over 5. Okay? And also, we don't use that. Also, it's going to be AB over DC, okay? But we don't need to find that. All right, so from here, you will see that x is going to be what? It's going to be 4 times 5 over 3, 20 over 3. Right, so let's be careful when you, Kevin, Zhang, okay? When you compare those two triangles, the corresponding sides, you have to figure out what are the corresponding sides. Okay, so x is going to be 20 over 3. Okay, that's correct. All right, so now I'm going to ask, we're going to do this one. Now we are ready to do the next one. All right, in the circle. So this is the AB and the DC, okay? AB, DC, okay, intersection at the point E, okay? So let's just say AD equals AE equals 3. You know, it's not exactly, right? We just draw the graph, okay? Okay. ED equals 4. ED equals 4. So this is the AD equals AE, 3, 3, 4. Okay, ED is 4. BC is going to be, wow. I'm not sure this is the correct picture, but BC is going to be 5. What is the area of the BCE? Okay. Yeah, just assume this is our picture, okay? I did not draw it correctly because it looks like ADE is isosceles triangle, but it does not look like an isosceles triangle. Maybe, okay, let's assume this picture, okay? Can I make it a isosceles triangle? I have to draw, yeah, it's possible. Okay. All right, so first of all, you should know that the triangle ADE is similar to the triangle CBE, okay? So the area of triangle CBE over the area of the triangle ADE is going to be the factor square of the factor, right? So that means which way is first? It's a 5 or 3 square, okay? Because this is the two sides of, corresponding to each other. And all we have to do is find the area of ADE. Okay, find the area of AD. So the area of triangle CBE is going to be 25 over 9 times the area ADE. So the triangle on the left hand side, but 3 sides are given, right? If you have 3, 3, 4, right, A and the DE, right? Can you find the area? Obvious. You can find the area. You just need to find the height, right? The height is going to be the square root of 3 square minus 2 square. So 9 minus 4 is square 5. So the area of this triangle ADE is going to be half of 4 times the height, 2 square 5. Right? Then you put it here. Then you get the area of triangle CBE, which is 25 over 9 times 2 square 5, 50 over 9 and the square 5. All right, so that's the area of the ADE is easy to find out. It's an isosceles triangle. Then as long as you recognize that those two triangles are similar, then you solve the problem. Now, I did not draw it carefully. If I draw it more carefully, I think I should draw like that, okay? And this is the AD, right? I have to draw an isosceles triangle. Then draw like that, okay? This is 3, 3, and 4. That looks better, okay? And this is going to be 5. So let's go over this. We learned that for this triangle, you see the similarity of two triangles inside a circle, okay? You see we use a similarity here again. Yeah, if you use similarity, then you can solve the problem. Next problem is how to find the radius of the circle inside of the triangle. Okay, you can begin with a right triangle. Okay, so this is a right triangle. Here's a 5. Here's 12. Okay, and then the other one may be 13. Right? And the 5 square plus 12 square equals 25 plus 144 is 169 to 13 square. So it's indeed a right triangle. So now you have the circle and square it. Find the radius. Okay, go ahead and do it. Okay. We get two different answers. 2, 3, 4. What? So sounds like you're not able to do. Okay. If you're able to do this problem, you're able to do the next one. Okay. So how do you find the radius? Well, if you have many ways to find out. First of all, you connect important points. Remember, connecting important points. So you draw the line. This way perpendicular. Okay. This is the radius, right? So there are many ways to solve the problem. I want to try to teach you two different ways to solve this problem. So first of all, you draw the lines between important points. Right? You will find out the triangle are congruent. Okay? So lots of triangle congruent. For example, like this one. You have two triangles that congruent. This is the first method I want to talk about. This triangle and that triangle congruent, right? What else? As you can see that, okay, if this is R, right? Here's R. Here's R. So this will be 5 minus R, right? And then this two triangle congruent is 5 minus R. Okay? What do you got? You got 0? I got all different answers here. Okay, I'm trying to find out two different ways to solve the problem. I use a very important property. If a circle and this center connected to a tangent point, then this must be perpendicular. Okay, so this is a special case. And what is this side? This side is 13 minus 5 minus R. That will be 13 minus 5, 8. 8 plus R, right? Okay, and this side is going to be 12 minus R, right? And those two triangles should be similar. So 8 plus R should be equal to 12 minus R. Got it? So 2R equals 4. R equals 2. That's the first method. Got it? I use this congruent of two triangles. Second method. Second method is the method I really want to know. Okay, you have a congruent triangle, right? Here's 5, here's 12, here's 13. Okay. I use the area of the triangle. If this is ABC, ABC equals half of 5 times 12, right? But I can find the area of these three triangles. Okay, I can find the area of these three triangles. They all have the same height, which is radius. So it's half of 12 times r, half of 13 times r, half of 5 times r. Okay, so that's going to be 12 plus 13 plus 5 times r. Let's simplify it. 12 plus 13, 25. 25 plus 5, 30. 30 divided 2 is 15. So 15. Okay, so r is going to be, okay, is going to be, this is right, solve it, right? So half of 5 times 12 and the 15. Simplify. Okay, so this is the half of 5 times 12 is 3 times 4, and 3 times 5 cancel, that's still 2. See, you get answer 2. Okay, so yeah, so you have two different answers. See, the second method, I really like it because this is the method we're going to use when the triangle is not the right triangle. Okay, and the first method is a little bit special. I just go around and finally I have too many congruent triangles. I use 2 pair of congruent triangles and get rid. I don't need to use a well, right? You see that we get both have the same answer. All right, so our next problem, I'm going to show you here. This is right triangle again. It's B 90 degree and A and B, A and C, okay? And AB is going to be 6 inches, right? And then the circle is inscribed here, and the radius of circle is going to be 2, right? Because you are given the area, right? Find the area of the triangle ABC. So we are what? We're not finding the radius, we're given the radius. That's fine. We are given the radius. How to solve this problem? We have to set up a lot of equations in order to solve it. Okay? And I know you did the problem, right? Some couldn't solve it, some couldn't. Okay? In order to find this area, this is right triangle, all you need to find the B. So this is a half of 6 times B, which is 3B, okay? So if you can find one side, then you get it, right? And this side is C. As long as, yeah, this is a Pythagorean theory, 6 squared plus B squared equals C squared. Let's write down this equation. I do have a, you see, how do you find the radius, right? We find the area in 2 different ways. So the area of the triangle ABC is going to be half of 6 times B, which is 3B, right? But this can be also equal to the sum of this area of the 3 triangles. So the first one is 6 times R. Second one is B times R. The third one is C times R. Okay? Since we already know R, so it's going to be, R is going to be 2, right? So it's a 6, I is 2, that's a B, I is 2, that's C, okay? All right, so what do we get? We get 3B equals 6 plus B plus C, and I get 2B plus minus 6 equals C. Okay. Well, that's good. Why? Because we have another equation, the Pythagorean theorem, right? So we have 2 equations. So I can use that one, 6 squared plus B squared equals C squared. C is 2B minus 6 squared. Okay, multiply this out, 4B squared minus twice of that, it's 24B plus 6 squared. So 6 squared canceled out, and I cannot cancel B squared, okay? I can move 24b, and here's 3b squared. And I can get rid of b. 24 equals 3b, and the b is going to be 8. So we solve. We find this triangle. This side is a 6, that side is 8. And clearly the other side. So now if we find this is a standard right triangle. So the area of triangle ABC is going to be half of 6 times 8. Okay, it's going to be 24. So we name some variables, but we have to get enough equations to determine these variables. For the triangle at the very beginning, we have a 6BC. We just want to find the B. But we have to also call it other side C. So we have a 6 squared plus B squared C squared. So the another equation we're going to establish is this equation. And where it's from? It's from the area. We take the area 2 different ways. Okay. And then you get another equation. Now this is the equation. How do we use that to find the radius? Since the radius is already known. Okay. So you just plug in, the unknown is B. Okay, so when you have a time, go through these 3 problems we discussed. Okay. All right. Another problem is, yeah, I forgot the picture. It's a 3D picture, okay? All right. Hold on, let me get the. Okay, the problem is I don't need to know the exact value. Okay, let's see A, B, C, D. A, B, yeah, we have 3 sides, right? It's not the exact same problem. Okay, so A, B, C, D, okay, E, F, G, H. Okay, it doesn't matter. Okay, so the idea is this is a picture. Let me draw this. I think it's like that. Looks like that. Okay, so find the. I know this this rectangle. Okay, so I can say this side is 12, and this side is, I can say this side is 8, and the other side is 6. Okay, so not exactly the same problem, you get ideas. All right, so find the volume. Volume of this one, B, E, F, H. Okay, how does it look like a BFH? This is a cone-like volume, okay? Cone-like volume, cone-like solid. Why? This is a vertical line, and you have another line, and you just draw it, right? Right? It's cone-like solid. For a cone-like solid, how do you find the volume? The cone-like solid, the volume is going to be 1/3 of the base area times height. Okay, this is the base area. This is the height, and divide by 3. That's a key point. But when you look at the picture here, inside the rectangle box, this is a cone-like solid, and you can also quickly get So you can get the base. The base is the right triangle, okay? Because this side is 12, okay? And this side there will be 8. So actually it's going to be 12. Yeah, this is 12, this is the H, that's E, that's F. Okay? So the area is going to be the area of triangle HEF. Okay? So it's going to be half of 12 times 8 and 4 times 12 is 48. So that is the base area. The height from the picture, you can tell this is just the height is going to be BH, which is AE, which is going to be 6. So therefore, the volume is going to be 1/3 the base area times the height, right? So the answer will be 2 times 48 is 96 square meter, okay? So this is about the solid. What is called a cone-like solid? Cone-like solid will be like that. Okay, let me talk about cone-like solid. Okay, for cone-like solid, first of all you have an irregular shape of a domain in R2. Okay, then you pick a point in the space. You draw all the lines. Okay, this is called a cone-like solid, and the height is this one. This is the height, and this is the base area. So the volume is going to be 1/3 of base area. Okay, and the pyramid is a cone-like solid. Okay, for the pyramid, square-based pyramid. Right, this is a cone-like solid. Okay, it could be anything like that. The triangles. Okay, this is also no, this is a cylinder. Okay, but you have to collect to one point. Right, cone-like solid. If you have if you have how many pieces of triangle you need, right? You need to form a solid. Okay. Isosceles triangle. Equilateral triangle. Let's use the equilateral triangle. Okay. Equilateral triangle. How can I draw equilateral triangle? It's harder to draw it. That's why I have troubles. All right. So this is also cone-like solid. Okay. All the faces are equilateral triangles. They're just put together. And we needed to know how to find the area, how to find the volume. Okay, so that's my question. Okay. The cone-like solid is enclosed by 1, 2, 3. How many? 4 equal regular triangles. Okay, with the edge length. With the edge length 1. Find the volume. Can you do that? Right, so equilateral triangle, we know how to find the area of equilateral triangle. It's 1, 1, right? I can use just A. Let's put the A here. Just A and A, right? So the area is going to be square root of 4 times A squared. That's not difficult. That's a base. My question is, how do you find the height of this solid consisting of, 4 equilateral triangles? Okay, can you find it? H, the height? Okay, I'm not sure you can get it. And let's see. I'm going to draw a line to the bottom. This should be laying in the foot should be in the center of the triangle, center of the triangle. Okay, right? So to find the H height, I need to apply the Pythagorean theorem to this vertical triangle. And that is going to be called X, and this side is A, right? So X squared plus H squared equals A squared. But what is X? X, if you look at the picture here, X is this part, okay? So we can figure out X here. Use the edge length A. Okay, and this is a 30-degree angle, so that's what be half of X. So I can find the relationship half of A squared plus half of X squared equals X squared. Okay. We apply the Pythagorean theorem to this problem. So I can get X squared now. Then I get I just get X squared. I just need X squared. All right, so half of this equals X squared minus a quarter of X squared, 3ax squared. So X squared is going to be 4 over 3 and 2a squared. After simplifying, 4 cancelled out, a squared over 3. Okay, that is X squared. And it's applied into here. So I get X squared equals a squared minus X squared, a squared minus 3. So it's 2 over 3 a squared. Okay, so you can get H. Okay, so that is the height. Then the volume is 1/3 of A times H, and A is the area as a base. Okay, and H is going to be square root 2 over 3. Okay, so now let's simplify it. I think square root 3 is gone. And that is the answer. Okay, so that is the answer. All right, I'm going to ask you to think about the last problem. Probably the last problem. Okay, we have a triangle. 15, not 15. 15. Okay, and the 41, and the 52. Find the area of this triangle. What is best likely? Yeah, do you have any other method, Maybe you can find 2 different ways to solve this problem. I'm going to show you 3 different ways to solve the problem. Okay? Okay. So if we know the following fact, okay, that's the first method. Some students know that. Okay? If we know that 9 squared plus 12 squared is equal to 15 squared, and the 9 squared plus 40 squared equals 41 squared, then you quickly can get the answer. Okay, so let's draw the line here. This is x, this is y. So 15, 12, 9. So you can see that h should be equal to 9. Okay, 12 plus, yeah, x is going to be 12, y is going to be 40. So add them together, you get 52. Then you're done. Okay? So that means this side is going to be 12, this side is going to be 40. Okay? So by guessing trifling. So once you get x, you get h, then the area is going to be half of 52 times the height. Okay? And you will get 234. That's a quick one. That's not easy. You have to know lots of special right triangles. Right? Suppose you don't know this fact, okay? And let's draw the picture. You still use a standard method, 4152, right? So you try to find the height. Because you don't know the height, you cannot find the area. So this is x and y, okay? Then apply the Pythagorean theorem, because x plus y equals 52. You get one equation. You have 3 unknowns here, right? The first Pythagorean theorem says that this is going to 15 squared. The second one is y squared plus h squared equals 41 squared. So you have 3 equations, 3 unknowns, and you're able to solve it, right? If you can find the x, then you can find h. So once you find the h, the area is done. Right? How do you find the x and the y? All right. Let's do the equation. 1, 2, 3. I'm just trying to take the difference here. Okay. I don't know why is probably y is larger. Okay. So let's use the equation 3 minus equation 2. So y squared minus x squared equals 41 squared minus 15 squared. Right. So you will get y minus x times y plus x equals 41 squared minus 15 squared. But the y plus x is already now 52. So y minus x is 41 squared minus 15 squared, 52. But you know that y plus x is equal to 52. So from here you can quickly get x and y. Then you solve the problem, okay? You just need to find the x, right? Find the y, it doesn't matter. Okay, find the y. Let's find the y. They add three equations together. So 2y okay, so it'd be 52 square plus 41 square minus 15 square. Actually, if you simplify the computation, this is nothing but 28, okay? Yeah. So 28 plus this total is going to be 80. Okay, you can quickly show that. So y is going to be 40. Okay, so once you find the y, then you can find the h. Look at the picture here, right? So this is a picture. Here's h, here's 40, and the 41, right? So h is going to square root 41 square minus 40 square. Okay, it's going to be 41 minus 40 times 41 plus 40, which is going to be 1 times 81, so it's going to be 9. So once you get an h, then you solve the problem. Okay, the key point is get enough equations for you to consider. 3 unknowns, 3 variables, three equations. All right, so once you find the h, then this is going to be half of the base, 52 times 9, and again, it is going to be, it is going to be 234. Now, what is the other method? Yeah, we are done almost, all right? So the other method, remember, the triangle is uniquely determined, okay? The triangles are uniquely determined by the 3 sides. So we have the formula, the so-called Heron's formula to find the area. Okay, the Heron's formula says that if you have 3 sides A and B and C, the area is going to be square root S, S minus A, S minus B, S minus C, and S is half of the perimeter. It's a very beautiful, nice formula. It's discovered by her, improved by him. Well, if you can prove it, show it to me, okay? If you have a time and trying to prove it, don't look at the internet. All right, so now S is half of 15 plus 41 plus 40, 52, and you can quickly add them together, divide by 2, so it will be 54, okay? Then the area is going to be 54 times 54 minus 15, and the 54 minus 41, 54 minus 40, 52. It's not big. You have to multiply this out, okay? 54, you can factor it. I think it's 6 times 8, right? And 54 minus 15, it's going to be 9. No, 20, sorry. What is that number? Yeah, 39. And that is going to be 13. And that is just only 2. Okay. You can you can get rid of radicals. The reason is 6 is 2 times 3, 8 is 2 cubed, 3 times 13 times 13 times 2. So you have a 13 square there, and you have a 3 square there, right? And then you have how many 2? Yeah, then you can also take a 2 out. Yeah, then this is a, let's see, what do we get here? Okay. Yeah, 69, that's right. All right. This is going to 3 square, that's why. Then we have, yes. Yeah, okay. Now it's correct. I was wondering why it's wrong here. Okay, so after you multiply this out, you get all the, you get perfect square inside. So you will get the same answer, 234. Okay, 234. So for one problem, you can have 3 different ways to solve it, right? For this particular problem. Now, maybe I can ask you, what is a circle? What is radius of circle in squaring this triangle? You know how to do it right now, right? You can divide this triangle into 3 triangles from the center of the circle. Then, and the radius is going to be the height of each triangle, then add the areas of 3 triangles together, then you already know the area of the whole triangle, right? So then you get equation, then you get radius, okay? So I stop here, and if you do have questions on some homework problem, please submit it to me, okay? Before Thursday, okay? So I can discuss. Now, some students ask me probability problems. Sorry, I cannot today, but maybe next class, if I get enough problems on probabilities, we'll go back to probability problems, okay? Okay, see you, bye.